Next speaker has been helping more than 100 DevOps vendors develop a whole range of add-ons for Bitbucket and Jira, and I can honestly say he's like one of the foremost experts in developing Atlassian Connect add-ons. He's also a colleague in my team, and please welcome Ian Buchanan.
Everyone. So thanks, folks. I'm here to tell a bit of my story. So as Nicholas said, I work with some of Atlassian's largest partners. I'm very happy to have worked on the AWS CodeStar integration that was announced quite recently. So I didn't really write the integration so much as help advise and consult on some of these big ones. And one of the things that I've noticed in kind of an overarching theme across these integrations that I've helped with is that this JWT thing kind of works in there, and people don't quite understand what it means. And yet it's really important to get this right. And I don't just mean theoretically. We did have an incident once with one vendor who will remain nameless, where a sensitive endpoint was showing username and passwords to anybody who would come into the endpoint. So it's very important to make sure that you have JWT authentication in the right places. It's also important to get this right so that when you have problems that go beyond what the Atlassian Connect framework will do for you, or Spring Boot, that you can get into the debugging of these things. Because at the fundamental level, JSON Web Tokens works at the web level. So with that, I want to start with the idea that JSON Web Tokens is an internet standard, more or less. So there's an IETF spec around this. And we'll start with, like before I go into the Atlassian specific concepts, we'll just kind of have a review of what JWT is about. So two characteristics that are very important here are compact and self-contained. So compact as in something that you can put in a URL parameter, you can put it into a HTTP header, and it must be URL safe and relatively small. If it gets too big, you can overflow the HTTP servers. And self-contained in the sense that it contains all the required information that you'll need with the source or the involved user, so avoiding all of the kind of back and forth that you might need if you have to query back for more user details. And in general, there are two uses. And if you kind of go out to the internet, the first one, authentication, is more or less obvious. That's what a lot of people are using it for. But it's multi-talented. And so JWT has a payload that can be used to exchange any information. But we have to be careful here. JWT tokens are URL encoded and not encrypted. So that means you can take a JWT token and put it into a tool like jwt.io and see all of its contents. It's not quite user visible, like if you're just looking at the token as it's encoded, it's not obvious what its contents are. But that means it's not really secret. So we have to treat it as such. But also this whole idea that it has the ability to exchange information, I don't mean that it replaces broad HTTP channels like query parameters or JSON payloads, just that it should be relevant information in this kind of authentication context. So let's talk a little bit about the structure here. There are three main parts of JWT tokens. There's a header, there's a claim set, and a signature. The three parts are all base64 URL encoded and are separated by dots. So the whole thing is URL safe. So the base64 encoding and the dots pretty much take care of that. The spec calls the middle a claim set, but you might also see it referred to in Atlassian documentation or in open source JWT libraries as the payload. So a little bit of interchangeability there. The header looks something like this. There's a type. And in this case, JWT simply refers to what to expect in the claim set. There's an algorithm, and in this case, we're using HS256 or SHA-256. That's what is common for Atlassian, but you might see other options there as well. So basically, we're just the only things in this header are the internal structure and the signing algorithm, and then, as I had indicated, these are base 64 URL encoded. So on the right side, we see a potential example of what that looks like to provide the header. So for the self-contained part, most of the information that you want to get access to is in the claim set. Again, the claim set is also base 64 URL encoded to produce the claim set string. The keys of this dictionary can contain reserved claim names that are found in the JWT specification. There can be standard claim names that are registered with IANA but are a little bit more flexible, or custom claim names like invented by an entity like Atlassian. And I'll come back to why that's important for Connect. And then there's the signature. And the signature is formed by taking the first two parts, the header and the claim set, as their base 64 URL encoded strings. And then we take a hash of that information, and that produces the signature. So since we had HS256 in the header, that's the mechanism that we're using to sign this particular JWT token. So JWT doesn't specify how the communicating systems would exchange a shared secret, so that's an implementation detail. That's one of those things that I'll explain in some of the Atlassian details. So a complete token looks something like this: the header plus the claim set plus the signature. That's JWT. And better yet, there are plenty of libraries for these so that you can do the standard manipulations in a library. You don't have to implement all of this yourself. But the tricky part of JWT is not really in these steps that I've shown so far, which means the tricky stuff isn't really in the libraries either. Those are usually pretty small. The tricky part is in making meaning of the claim set. So let's talk about that in terms of some of the standard claims. There are time-based claims. Three of the examples are things like the issued at, which tells when the issuer produced this particular JWT token. There's a expired, or for short, just EXP, and a not before, or NBF. And these specify a window for which the JSON token, or JSON Web Token, will be valid. But the specification doesn't really say what windows should be, or how long, or if you have to have them at all. And so that's a negotiation between client and server. The other kind of standard claims are about different people, different agents that can be involved in the communication. One of them is the issuer. So that's who's issuing the claim, who's making a set of claims here. There's the audience, and that's more like the target, who is the entity that, or the agent that will receive the JWT token. And then there's the subject, and that might be a kind of third party. In the example of Atlassian Connect, that's usually the user who's on the page, while the issuer might be something like your add-on or Jira that is involved in the exchange. So an example of all three put together is here. We have an expired and an issued at claim. We have two agent-based claims, so there's subject there is I Buchanan. Again, this is an aspect that has to be left up to negotiation between client and server. So it should be understood that subject coming from Jira is a username. That's not in the JWT token itself, but in our explanation of what the claim sets are. So another example would be the issuer here, which is a long GUID-looking kind of string. So that's not a username. That's a particular tenant of Jira. And then the last one is a custom claim called QSH. We'll come back and look at that in more detail later. But again, so let me reinforce that this is really the meat of the talk now, is which claims go where for different kinds of flows. So that's what to pay attention to, are the claim set. Okay, a few pro tips around JWT in general. So this is even before we get into Atlassian use of it. One is that there is an algorithm that the specification allows called none. And effectively, it means I'm going to make some assertions, and I give you no information about who I am, so you just take my word for it. There are some valid use cases for this, but not with Atlassian Connect. And therefore, most of the times what you want to do is not accept the none, for Atlassian Connect, you never want to accept the none algorithm. And most of the time, libraries will actually prevent this. It's already kind of a safety feature built into lots of libraries. You usually have to tell them that none is okay explicitly, so they'll keep you safe. But just since that's only most of the time, I just want to make sure that people get this right. So my suggestion is, even with a library, I suggest you would write a test to be sure that you don't accept none. Another pro tip is about checking your clock time. And this is a thing that can bite a lot of developers. If you are a corporate developer, sometimes machines in the corporate network are locked down. They'll have time synchronization turned on, and that's fine. But developers are often disconnected from that kind of lockdown. And so developers can be more subject to clock drift than maybe anybody else. The problem with clock drift is that you'll see some errors about, like unauthenticated connections, and sometimes it'll work or sometimes it won't. And you won't really have any clue that clock drift is the problem. So my recommendation is the first thing that you do whenever you have auth problems is check your clock. So the next one is that there are also a kind of attack vector that JWT can be subject to called replay attacks, which basically means if maybe I send a JWT token to create a user, if somebody were sniffing that traffic, they could send the same signal to create the user again. For idempotent operations, maybe that's not painful, but if I've created, then deleted the user, the malicious actor could then recreate that user. That might be a real problem. And for that reason, the JWT specification has a claim called JTI, but it's very heavy to implement, both for you as an add-on vendor and for us as the Atlassian providers. And so instead of doing that, what we've done is kept the time windows relatively short, about 10 minutes. That can get, I think there are some valid uses of Connect where you're kind of keeping open a long session, and that's going to be a problem in this context, something you're going to have to work around. But keeping the time windows short actually kind of puts some additional pressure on checking the clock. So because the windows are so short, it makes the clock sensitivity even more important to check. Okay, so that's some pro tips in general. Let's start looking at JWT with Atlassian Connect in particular. So again, I come back to this, that there's this idea of authentication and information exchange. Connect needs both of these. So JWT enables authentication in both directions. So this is one thing, why not basic authentication or OAuth? Well, we want to be able to send information to your add-on with the same authentication mechanism that you can send us information back. So again, the key to all of this is getting the claim set right, since the libraries pretty much handle everything else. So let's see how we do that. First is understanding that there's a kind of lifecycle here. This lifecycle callbacks are going to send us some important information as an add-on is installed. So that's where the trust relationship is established between the two entities, between Atlassian and your add-on. Then each direction has a custom Atlassian claim called the query string hash that helps prevent URL tampering. And then the shared secret is used to sign the tokens in both directions. All right, so let's drill down on the lifecycle callbacks. In Atlassian Connect descriptors, that's specified under this lifecycle section. There are 4 different kinds of lifecycle events that you can listen to, but only installed has this special significance about establishing the shared secret. So it's the one you really have to pay attention to. Pretty much what's going on here is described in the sequence diagram. So an admin installs your add-on. The Jira instance sends an installed callback to your add-on with the payload. Your add-on will need to store some important information from that payload, at the very least the shared secret information. And it's part of the contract that your add-on sent back 200 OK or 204 also OK. And that's what signals to the admin that the add-on is installed. Right, and so when we have a look at what's in the payload, there's quite a few things here marked key, so it can get a little bit confusing. The key that you're sent should be the key that is your add-on. The client key is an identity of the tenant that you're talking to, but it's the shared secret that we need to keep by that client key. So client key is really the tenant identification. It's probably be the primary key in your database. And then there's also a public key which you won't actually need in here. So and that can be confusing because it looks like a cryptographic key, but it's shared secret that you want for the case of JWT. Okay, so when I said that there's a shared secret here, when we're sending or receiving requests, there is a special claim called the query string hash, or QSH. And why do we need a custom claim anyway? What's wrong with all the standard ones? Well, what we're trying to do is prevent HTTP tampering. And why? Because UI modules for Atlassian Connect are in the browser where people can tamper. So that's neither you nor us, but yet a third person who can be involved in this exchange. And so if they are able to open up Chrome developer tools, as I've done in this example here, using the poor folks at Spartez they do all the right things, so I knew this would be safe, but I can actually edit the code that's going to make a request and put in hijackmyrequest.com or whatever malicious URL I want to put in there. If they were not checking that request had a JWT token on it, then I might be able to hijack somebody else's instance or look at data for some other user. So that's why this URL tampering is so important to avoid. So query string hash, what is it really? It's a hash of something called a canonical request. And a canonical request is made from three basic parts. It's a canonical method, canonical URL, and a canonical query. And when I say canonical, what I really mean here is that we've removed redundancy or ambiguity that are allowed in URLs, so that we reduce it to one string that means the same thing no matter how it's expressed. So canonical method is pretty simple. Just make sure the HTTP method is uppercase. And technically, that's how the HTTP protocol is specified, but conventions of some programming languages or libraries may simply return a string without case sensitivity, hence the need to make sure that it's uppercase. The canonical URL is a relative URL to the base URL. So let's consider a few examples where the request URL is against your add-on's URL. So if our add-on is addonexample.com/Jira connector, if that's the base URL, then these three requests get modified in the following ways. One, we take the relative part off, so we're going to remove that. And then two, we do a couple of adjustments. If there's no string, then we're going to add a slash. So these always begin with a slash, which may be a little bit different from the way that you've seen relative URLs in other contexts. The other thing that we did was change an ampersand into its %encoded %26 here for title and description. It's kind of a corner case, but it's important to catch all of those. And then the most complicated piece that we have is the canonical query. This is the thing that really needs disambiguation. So if we have on the left side the query the query string, I've added some new lines here to make it all more readable. Then we do a few transformations here. One is that we're going to URL encode special characters. So on the left side, I have the ampersand. It becomes %40. Then we're going to order the keys. So expand becomes the first key, order by the next, and so on. We're going to combine and order values. So typically, expand and its multi-valued nature would be expressed by having multiple parameters, like expand rendered fields and expand names. In the canonical query, we order those alphabetically and we comma separate them. And then we drop JWT. So there's a kind of fake JWT included on there, but since all of this query string hash goes in the JWT, it would be some kind of crazy circular reference. So if there is one, we drop it. All right, so that's what gives us a canonical request. Again, that it consists of the method, the URL, and the query. In the simplest possible, shortest canonical request that I can imagine, you might have post, ampersand, slash, ampersand, and then blank, like when there are no query parameters whatsoever for a post. Or in a more realistic example, like the one we just worked, the canonical query is get, ampersand, a path, ampersand, and then all of those ordered parameters. All right, so then we take that normalized or the canonicalized request, and we hash that, and that keeps the string nice and short. No matter how long the request path or the query gets, we always get it down to a very short size. And then that goes in the claim set as QSH. And that's sent along with some of the other claims, the time and the agents. And then the QSH might ensure that the request wasn't modified, but it doesn't do anything about telling us that it came from Jira. So that's where signing comes in. And the standard explains there's different algorithms there, but in the Atlassian world, expect that it will pretty much be SHA-256 for the foreseeable future. And that cryptographic key that we do the signing with comes from that initial installed payback or payload. Right, so we put that together then with the, and we're going to get that per tenant. So each tenant has its own shared secret. Therefore, each JWT for each different tenant is going to be unique. All right, some pro tips about applying all of this in the Atlassian world. One is that because of this whole shared secret business and the tenants, I highly recommend using some specialized secret storage. If you can go to your database and see in plain text all of the customer data, you're putting all of your eggs in the basket of keeping your database connection secure. So perhaps something like HashiCorp Vault, or there are other cloud-based storage solutions that are specialized to encrypting client data at rest. Also, Atlassian's JWT libraries are generally wrappers for standard ones, but they also include methods that calculate the QSH for you. So if in the uncommon case that you have to create your own QSH library, there are some good cross-platform tests that exist in all of those library code projects. So you want to take those and kind of inject them into your tests so that you've proven that you have implemented QSH correctly. The docs are pretty good at this. I know that because I wrote them, but I would rather folks use automated tests than refer to the documentation. And then the last one is that there's a kind of special case where when admins are reinstalling an add-on, that is they may hit uninstall first, then the next time you receive an install callback, it will be signed with the old shared secret. And so if you get an installed callback from a tenant that has already existed, you want to check that JWT. Yeah, so those are the cases. All right, so there are 3 flows where JWT comes in handy, where it's going to be used. One is when Atlassian makes a request to your add-on. The next one is when your add-on makes a request to Atlassian, and by default, it's making a request as its own, basically as itself, as if your add-on were a user. And in the third case, your add-on makes a request to Atlassian as a user. That's known as user impersonation. and uses a OAuth 2 based flow. All right, so if you're making an Atlassian request, there's some sample code that shows how this works. But first, let's just talk about what the uses of that are. So there are two. Pretty much if you have implemented your own UI modules, these are the ways that you extend the user interface of Jira, Confluence, or Bitbucket, or HipChat. Then you're going to be receiving requests from an Atlassian product that are signed with JWT. Or if you're receiving webhooks and have turned on JWT authentication, then those will also carry the header for that. And to do that, you'll find that you can implement, from the Connect descriptor, you implement a module for web panels that has a URL. That's the URL where, like, for example, that's part of the relative URL that will get signed. Also, the webhook side, kind of simpler way of describing that, but it's also got the URL. That's where it's going to send that JWT signature. All right, so let's have a look at what that flow means in an example application. So step one, we're going to start the add-on. I've had my logging spit out what the URL descriptor is. So I copy and paste that. I'm going to upload that into the admin screen as a new add-on. Then as it goes through installation, you'll see it catch the installed and updated and enabled Lifecycle events. Those will give me which client ID that I'm on. Then I make a change. This one's going to catch a webhook. And then I'll have a rather complicated series of things to do. I have to make sure that for that webhook, for the tenant that sent that webhook, that the JWT that it's sent is signed with the proper key. And we see most of these at the bottom, so verified JWT signature. We check the QSH claim to make sure that it wasn't tampered with over the wire. And then we check the time claims, the issued at and the expired claims, that they actually make sense for a reasonable time range. And what we find in this case is, okay, so that gives us the information about which tenant sent us this, and now we know that information is correct. All right, so just kind of in a little bit of pseudocode here. I usually wrap up the QSH building with my own object code to kind of make it simpler, but basically we have to pass in the same information that I've already described. So it's the base URL, the request method, the path, and the query, and that gives me a QSH string. I'm going to decode the JWT token from the authorization header. I find the shared secret for that particular tenant, and then I verify with the secret that it matches, and I verify that the QSH matches the request that came in, and then I do whatever with the webhook that my application should do. So the first 4 lines really represent what you have to check with every incoming request. Okay, so and this is the part to remember, because this is where end applications have an endpoint that they can hit. So and don't consider those endpoints to be private exactly either. The Connect descriptor is really served up on a public server, so people could have a look in there and like do some kind of manual parsing to understand which endpoints your add-on has. And this is the place where if you don't do the JWT and QSH checking, you might leak sensitive data. So please don't. Okay, in the other direction, if your add-on is making a request to Atlassian, I've written some sample code for that as well. In this case, I kind of call it ping. I'm just checking the myself endpoint to make sure that I can talk to to Jira in this case. And effectively, this is just whenever you want to make a backend REST API request, you'll have to sign it with the JWT token. The flow is slightly different because we're not unpacking a JWT token from Atlassian. We now have to pack up our own. So let's see how that looks. Okay, again, we will start up the add-on. I'll log out the Connect descriptor again, copy that and install it. Steps are still pretty similar about catching the install payload and getting the shared secret out of that. But in this case, I also need to know the base URL for that tenant so that I can call it back later. So another thing that I store in this flow is the base URL per tenant. So then I have made a simple REST endpoint on my add-on that just kind of simulates what it might, something that might trigger a request. So I trigger ping for a particular tenant, and what we see finally is that in this case, JWT, I have had to construct my own JWT. So I build up my canonical request. I turn that into the QSH. I pack that into a JWT token with expired and issued at date, and send it over on the myself endpoint. And in this case, it says acting as Jira ping gateway. So this is the case where the add-on is acting as the add-on itself. Okay, so in this pseudocode again, we kind of see what that flow is like. Now I have to look up the base URL so that I can make the request to the right instance of Jira. I also have to look up the secret. I'm going to kind of begin I have wrapped up the ping idea in a kind of object there to make it easier for me. I have to build that Jira QSH, so I'm going to need the base URL, the method, and the request URL again. In this case, there are no query parameters to pass, so I build that out. Then I make the JWT by sending the descriptor key and the QSH, and then I go ahead and ping by sending that as part of the auth header. Okay, so JWT handles, or libraries handle most of the structure and signing stuff for you. So really, I think the hard parts in this flow are about saving the right information during the install callback, and then finding the right shared secret again. I've done it with an in-memory database, so as soon as my add-on crashes, all of that is lost. That's not the way I would implement it for production. But what's hard is that claim set, because you have to get the right things in there, and even in the JWT libraries provided by Atlassian, we don't do much to help structure those for you. And again, that comes back to why I generally write my own wrapper around that. Okay, and the third flow is this impersonating a user. And the example for that, again, with backend REST API requests, but ones that you want to do on behalf of a particular user. An example would be if you want to create an issue, and you want to make sure that the reporter has the right username on it. You can't set that later. You'll have to do it as the user, or by making the request as the right user. All right, so this flow is a bit more complicated. Well, let's see it in action. Again, we start up the add-on. This time, we get a different add-on descriptor. We'll paste that in to install it. We get the same install callback and save the base URL and client ID. This time we also get something in that payload called the OAuth client ID. So we're making a request on a slightly different endpoint, and we'll need that OAuth client ID later to identify who we are. So then we trigger a request using that client ID and the user that we want to make a request on behalf of. So that's me in this case, and we'll do the triggering again. Okay, so this is like first half, because what we get is a key that we need to now turn around and make the real API request with by sending this in the authorization header. So this next API request will be made on behalf of Buchannan. So the first part gives us a special token that we have to use, and then we make another request. So this was the one that gives us the access token. We hit ping now, and we send with that very long token. And in this case, we see that finally, when we get down to the bottom, we say acting as Ian Buchanan. So in this case, the ping went through instead of as the add-on, as a specified user. So I kind of offer a word of caution on this one. The OAuth flow certainly has its uses, but think carefully before you're going to go into it. If it's something that you really must do, it's there and available. But it does add an additional layer of complexity to the authorization handshake. And the claim set is different from regular REST requests. The additional step of obtaining a token has these kind of obscure consequences. So again, if the time is off or you have some problems getting that authorization token in the first place, then the rest of your request won't complete. And there's something to know, I guess, kind of like sharing a little bit of our dirty laundry, I suppose, but it's as we refactor into more of a multi-tenant architecture, the OAuth part isn't natively part of Jira. So you're actually going to call into a common shared service for all of the Jira instances everywhere. And that means there can be strange behind-the-scenes interactions between our OAuth service and the target product that you're trying to reach. So from time to time, that just may mean some additional sets of errors that you have to deal with. And if you are making a request that works with other auth mechanisms but then doesn't work with OAuth, please do report it as a bug. All right, so that's just a quick recap. That's the 3 flows that use JWT. So at this point, I'll open up for questions if there are any.